Hello.
Hello, good afternoon,
Everyone.
everybody.
Welcome, everyone. We will just wait a couple of minutes to see if other people join. Feel free to say hello in the chat in the meantime and where you're joining from.
Good to know that the fire alarm is still working in the office, James.
Welcome, Rolf. While we are just waiting a couple of minutes, maybe we can do some quick introductions. So, yeah, welcome to today's webinar focused on secure Kafka data sharing in 60 seconds without duplication. I'm James, I'm Director of Product at Conduktor, and very happy to be sharing the stage with Christoph today. Christoph, do you want to introduce yourself?
Yeah, so hi, nice to meet you all, guys. Happy to present today to you together with James. I'm Christoph, Head of Sales Engineering here at Conduktor.
Good stuff. As we said, if you've just joined, feel free to introduce yourself into the chat. We're going to get started in a few seconds. Okay, I think we'll get started. So, as I said, thank you all for joining today to this Conduktor webinar. We are going to look at secure Kafka data sharing in 60 seconds without duplication. So let's get into it. So let's set a bit of context around the need for data sharing. So you'll see we've got this lovely quote here by Garner, which talks about the importance of third-party data sharing, estimating that by 2026, 30% of global enterprises will prioritize collaboration and secure data sharing. But what are some of the reasons driving this? Number one, obviously, data innovation. So looking at how you can turn that first-party data inside your organization into a revenue-generating asset, or consuming from a third party and using that third-party data to help enrich your models or empower your decision-making. Of course, streamlining those external partnerships. So, looking to achieve mutually beneficial business goals, empower your real-time decision-making. And of course, the third one here, compliance and regulatory requirements. So financial institutions may need to share transaction details with regulatory bodies. Of course, the data sharing, it's nothing new. Most of us probably were around the days of FTP, nightly data dumps, batch data sharing. But we are seeing a shift away from kind of those ETL type process and towards kind of streaming being used as a mechanism for data sharing. What's driving this? I think multiple things, advancements in technology, but also in consumer expectations. So you've got a proliferation of edge and IoT devices, data being generated everywhere. You've got AI and ML models. They're dependent on real-time contextual data. And obviously a strong demand for kind of personalized user experiences. So we see a huge amount of use cases across the board. Hopefully you can see your industry somewhere here. I'm not going to comment on all of them, but maybe to pick out a few that I think are super interesting. On the data monetization front, so the New York Stock Exchange is doing this today. If you've seen, they have announced a product called New York Stock Exchange Cloud Streaming. Essentially, they're offering accessibility to their exchange data feeds through Kafka natively on AWS. Many people will be familiar with the fraud detection use case. So sharing that transaction data with fraud detection platforms to determine the validity of a transaction in real time. And one that personally I've learned more about recently, healthcare. So the No Surprises Act in the US. The US is essentially aiming to enhance the flowing of data between health insurers and healthcare providers. The benefit being protecting patients from surprise medical bills when receiving, out-of-network care. Super interesting. So this is something we're seeing a lot of demand for.
So, and basically, how can this be done, right? So how can we nowadays share data with Kafka? How it's typically done? Well, of course, what we don't want, if we have external partners who we might not really trust in configuring the Kafka clients correctly, and we don't want to give them access to our internal Kafka cluster, which we see here on the left-hand side. So typically what we could do is we could deploy one or more Kafka clusters in a neutral zone, so aka DMZ, or maybe in a public-facing VPC in the cloud. So we have a spin up additional Kafka cluster here, and then we need to have some kind of data replication mechanism. That could be the open source mirror maker or conflict replicator to copy data here. And then finally, we would give our external partners or customers access to this external Kafka cluster in the DMZ. And of course, that has a couple of drawbacks, right? So our operational complexity is much higher. Instead of just managing one Kafka cluster, we now have at least two, maybe more if you want to give a separate zones or separate deployments for each partner. And we also have to take care of the mirror maker or general replication scenario here. Now, this is also going to increase latency and as well as cost, right? We have additional infrastructure and maybe even additional licenses for which we have to pay for.
I got a couple of questions on you on that slide, Christoph, before.
Oh, yeah.
Well, maybe. So maybe to dig it, like how would usually the credential management for a third-party consumer work in this scenario where you're replicating data to another physical Kafka cluster?
Yeah, it depends a little bit. So, many of the decentralized solutions which we have, like MTLS or IDC, might not really be applicable because we don't want to give external applications or the external partners access to our OIDC, to our PKI or to our identity provider. So typically they would have to be created by hand. And then Kafka is, I would say, notorious for not giving you a nice API for doing this, on the fly. And then, of course, they would be, have to be kind of transferred, in some way to the external partners as well.
Nice. And the other thing I'm thinking of is this is an ideal scenario where the data you need to share looks exactly the same as the data you're replicating. But in a case where you had to maybe remove some of the information because it's sensitive fields or things like that, how might this pipeline change if you needed to do some kind of filtering or transformation?
Yeah, there are different ways of doing that one. The simplest way maybe, but again, practice shows that can be a kind of a maintenance nightmare, is to use transformations here on the replicator, but that's, again, typically pretty difficult to set up. You could also have an additional streaming solution, right, and either basically working on this Kafka cluster or on the internal one to mask and filter the data using KSQLDB, Kafka Streams, Flink, you name it, basically. But of course, the problem there is this is very powerful, but that's, again, more hardware, more latency, which you induce, and also more cost.
Great, thanks.
Are you done with grilling me, or you want to continue?
I'm done. Let's move on.
Okay.
Great. So I guess what we're going to talk about today is the flip side to how you might do it today, which is obviously Conduktor's solution, Conduktor Exchange. So if we dive into this, the Exchange product for Conduktor is all about secure sharing of streaming data with your third-party partners. And we do this through multiple ways. Number one being simplified management of the resources that you need to share. We do this through this notion of a partner zone, which is exactly what Christoph's going to demonstrate in a moment. Partner zones are essentially dedicated zones for the customers that you need to share data with, and they're customized in that they have access only to a specific subset of topic resources. You can then obviously control access to them through secure credential management. And obviously, if you have sensitive internal semantics, topic names, and things like that, there's capabilities in there to help you rename that and make sure that you're sharing something that makes sense for that third-party customer or partner. And of course, the main value driver here in terms of what we're providing with our solution is, you don't need to replicate the data. We're providing just one source of truth, and you'll see how we do this through our proxy. And then, of course, you're avoiding all of the operational and the actual financial costs of that replication process. Lastly, obviously, you're getting the benefits of the Conduktor platform wrapped into the solution. So you get that embedded governance. And then the point I was making with Christoph on data processing, we have capabilities to help you filter, mask, obfuscate the data that you do need to share to make sure that you're just sharing what you need in a secure way. So I think over to you, Christoph, for a demo.
Yeah, maybe first a little bit of architecture overview, so to say. How does it look like? So again, we don't want to give access to our internal Kafka cluster, right? We want to have a kind of isolation layer in between. So now this is basically done by our proxy, Conduktor Exchange. And on these ones, we can define these additional partner zones, right? And we have the ability to control traffic, define quality routes, and so on. So we can drill a little bit deep into the capabilities later. The interesting thing is we don't have a data replication going on here, no? So basically requests are being forwarded to the Kafka cluster. We make sure with the traffic control policies that we don't overwhelm the internal Kafka cluster. And the whole setup is just much simpler and much cheaper in terms of infrastructure costs. And now I would like to give you a demo how we can basically create this kind of partner zone in 60 seconds. So, okay, take your stopwatches out. So actually 2 ways how this can be created. One is inside the UI, and the other one is via GitOps, basically via partner zone, so to say. So let me choose the right Kafka cluster. Oh my God, look, what did I do? Forgot to set up my demo correctly. So you have to talk to me or watch me talking about a little more.
Think on your feet.
Yeah, keep me on my feet, right? So, I mean, a demo which is not halfway botched, it's not a proper demo, I would say. So maybe I can quickly show you what we see here, right? We have a small Kafka cluster or local internal Kafka cluster, and you can see we have 6 topics here, right? So we have reviews from partner, where we want to receive data from our external partner. We have our products for the partner, which we want to share with the partner. Yeah, and we have a couple of other topics which are at the moment purely internal, right? I mean, the payroll, employee information, for sure we want to make sure that partners don't have access to these ones, right? Let me quickly see if my gateway has been started. Yeah, that should be the case. So one thing here, let me quickly reload. Okay, and now here you can see we have another Kafka cluster or gateways here as well. So we are now ready to create our partner zone. So please reset your stopwatches, so to say. Let's go to partner zone. And here we see we have already one running here, so we can have more than one. Create a new one. And I would like to call this maybe just reviews, right? So you can see here we have a name for a service account. We have the ability to add further contact information if I wanted to. But let's skip this one now. And we have the ability to choose a gateway. Now here, basically, I have a list of all my topics which I could share. And let me add the products for partners and the reviews from partners here. And products for partner, of course, should be readable by the partner. Reviews from partner should be writable. Right, so let's go here, continue. And let's also make sure that we set some traffic control policies. So by default, basically, we're limiting reads and writes to 1 megabyte per second, but maybe let's also limit the produce rate a little more, right? So 50K or around 50K per second, that's enough. We don't expect more here. So continue. We have the ability to review and create. Looks all good as far as I can say. Let's hit create. And what we have done now here is we have to wait a little bit for this to be created. We now are presented with a screen where we see the username basically, now, which we can give to our partner. We have a snippet for the Kafka client configuration, and we have a password, which I'm going to copy and save somewhere. And now what we are going to do is, let's download this one here. Let's first, again, use our UI to basically give the part or show the kind of partner view which we are going to have. For that one, I'm going to add a new Kafka cluster here. And I'm going to just call this point partner. And then, of course, I need to have the bootstrap server, which I kind of downloaded before, hopefully. So here, this is the gateway. We are going to authenticate with Suzzle. For the demo now, we didn't bother to set up SSL, so it's the plain text, Scram, and I should get the username, which I got downloaded before, and also the password, which I've copied or downloaded before. So, and now we can just quickly test the connection. That looks good. Create configuration and save. And now if I go back here, you can see I have my new partner Kafka cluster with just my two topics here, right? So we are still, console is still checking how much data we have here. Let's see, I can help him a little bit. No, not yet. But you can basically see here inside, oh, I have my data, no, about 30,000 records here, 36,000 records. And this would really be the view that the partner sees. Now let's see. I said we could also produce, and I also would like to show you the rate limiting. And for that one, I quickly have to go back, basically off screen and create a properties file which is containing the right password which we just created. So let's do that one. And then here, let me again grab a command. Going to quickly run something here, right? So basically, I'm going to use the Kafka producer performance test, which is throughput one is going to hammer the Kafka cluster with as many records as possible. Yeah, and you can basically see, or maybe you believe me, this is really the open source Kafka tooling. So, and even though I'm trying to produce a record size of about 1K as fast as possible, I'm being throttled here to about 50K. The difference between 50 and 0.6 is we and the 2, we slightly measure the record size slightly differently. This one is including the metadata, we take the kind of raw data. Yeah, and if we go back here to the topics in my partner zone, you can also now see here that I have some random data. So the idea is we are not really showing you this data right now because it's randomized anyhow. Good. So, and that basically, I don't know how long it actually took me to create the partner zone, but I would say...
I'm sure it was 60 seconds, yeah.
Yeah, I think creation is fast, but then of course you have to copy the credentials and so on.
Nice.
So
you had one question in the chat while you were that about whether we follow open API architecture to enable you to kind of manage partner zones through the API as well. Of course, which we do.
Yeah.
And one thing you touched on obviously was the traffic control policies. I mean, out of interest, like, what are the best practices for rate limiting or throttling if you're thinking about, sharing data directly via Kafka with a partner?
Yeah. So typically consume, of course, we know we're just consuming the data which is there. So having a higher limit, I think, is fine. Also allows the partner to catch up quickly. Produce, you really have to see, of course, we don't want to have a misconfigured Kafka client spamming us. So I would say do something like I did here. Have a more, let's say, low, is it conservative? Is conservative the right word? More protective setting there. And then another thing which is also often overlooked is also the impact of committing offsets. You might have seen or remember that we set this one to 30 offset commits per minute. Why is that important? Because for Kafka brokers are typically not limited by the data, but the amount of requests. So meaning fetching 1 megabyte of data, that's one request, and it's almost as expensive as committing one offset, so to say. So we also want to limit, let's say, misconfigured clients who can produce a lot of load on the Kafka cluster by, not playing nicely according to the Kafka rules.
Awesome. Thank you. Right.
Good. So
I think to summarize, I mean, hopefully everyone who just witnessed the demo, this will be extremely obvious right now, but the huge change here in the before versus the with Conduktor scenario is, we're not replicating that data to an external Kafka cluster. That is something that will come with additional infrastructure costs, and obviously the operational complexity of maintaining that replication process as well, potentially using new infra if you're not familiar with things like Mirror Maker already. Obviously, the advantage of this being, you can share data from your source of truth in an isolated environment still, in a much faster environment. So that time to, getting that data product to market can be much quicker. You can benefit from the centralized governance that you have from having all of those partner zones consolidated inside Conduktor. And then you can obviously benefit from some of those complementary features in there as well. So, insights into like a partner's activity. Being able to audit, how frequently they are producing or consuming from your partner zone. So lots and lots of benefits. So, we're super excited to share that with everyone on the call today.
Yeah, and maybe one kind of example, right? So how an automotive company is using this one. So basically, you can imagine, most of the manufacturing and especially also automotive companies use some form of just-in-time logistics or delivery. Plus also internally the factories connect a lot of data, which often can overwhelm, let's say, traditional API-based or HTTP-based solutions. And basically here they used Conduktor to use the Kafka protocol, as a very low overhead and effective way to sharing data. Also, by not going this kind of replication route, they could minimize the number of network dependencies and have full control and transparency. Good.
Nice.
And one for you, James.
Yeah, I think so. One other use case from another industry. So we're working with one of the largest retail banks in the UK at the moment. They were already working with a couple of different SaaS providers for data sharing purposes, but they'd hit a limit in terms of using a traditional API, REST API gateway in terms of the number of transactions that they could be processed per second. They're also extremely security conscious. Of course, they are a bank, so they needed something that could kind of act as a buffer, do the policy validation, make use of some of those additional capabilities, encrypt the incoming data before it reaches the internal production Kafka cluster. So as a result, obviously Conduktor has become a big part of their toolbox to accelerate the delivery of data products to market as well, and help to equip the teams to communicate, with those external applications in real time, enabling use cases, at least in the retail industry, like Forgotten Basket and asset-based landing. It's a digital application for the bank, if that wasn't super clear. But yeah, another real success story in the financial services world. So I think that is.
I think that's it, more or less. No.
Yes, but I can see we've got at least one question at the moment in the chat. If anyone has any other questions, then please feel free to send them through, because we do have some time. So Malik's got a question, Christoph, perhaps you can help with. Could you tell us more about the neutral zone, so the DMZ?
Yeah, maybe I can just go back so we can look at the architecture diagram here. Oh,
yes,
not too much. No, actually, we don't really have any limitations there. No, besides the obvious one, right? I mean, we have to have connectivity to the Kafka cluster and also to the outside world. Otherwise, you're completely free. There, now the proxy is shipped as a Docker container, so we have customers just running it on Docker Compose. Other ones are using Kubernetes. No, I think actually maybe 2/3 of our deployment nowadays are running on Kubernetes, but that's not a must, so to say. So we are really free and low overhead.
Maybe a bit related to that, but given we saw the kind of before-after scenario, what is it you think that kind of managing, the proxy in this case is easier than the replication process of running Mirror Maker or another service?
Yeah. So honestly, I think Mirror Maker and the proxy are pretty close in a certain way. I mean, both are stateless services where the whole state which they need, for instance, for configurations, is actually backed by the Kafka cluster. So it's very easy to scale them up and down. Actually, it's easier or quicker to scale the proxy up and down, because, as I said, stateless, no? So which mirror maker is only partially, I would say. We still have to take care of the offsets. And in both cases, basically, we don't have to, in this case, we don't have to manage the heavy bit of infrastructure, right? Which is Kafka, which comes, is a distributed system, where it comes with either Zookeeper or a craft controller as well, and so on, where we have to maybe think about things like backup or how at least have a strategy to rehydrate this kind of partner zone, DMZ zone there.
Makes sense. Thank you. And I think we've got one more there. So do we offer a managed proxy service or an out-of-the-box config that handles auto-scaling?
Yeah, so at the moment, it's all self-managed. I mean, James maybe can comment if we have any plans to change this one in the future, or how we could change this one. To be completely fair, we thought about and we had an offering which was auto-managed, but it was not super well received, because the problem is Conduktor is acting as a client, right? So you're going to have an incoming connection from some external service to your private network, and this is what most security teams would frown upon, so to say. But here's the nice things, of course, you're still having this incoming connection, but you can basically, you know the IP address where it's coming from.
Yep. Thank you. And somewhat related to the subject of today, at least we've touched upon it. So we touched upon one of the capabilities being, inside the proxy, obviously, is being able to do, field level obfuscation of data. So obviously there's other ways to solve this problem. You can push this back to your clients, right? And you can build your own library, or you can use something like Confluence client-side field level encryption. That's obviously a slightly different approach to how Conduktor do this through the proxy. So, what do you see as pros and cons of both of these solutions?
Yeah, so of course,
I can give you my perspective on it first, and then you can maybe add.
You go ahead first, and then I can maybe add something.
Well, I guess one point would be that kind of central layer of enforcement, right? If you're doing this centrally through the proxy. So in terms of almost having sort of that firewall if all of your applications are going through the proxy, as opposed to pushing that down to the client where, your encryption strategy is as good as your least informed client. That would be one comment I have out of the box. Maybe you have something to add, Christoph.
Yeah. First of all, of course, everything which is client-based has to be available for the client, right? So if you use Kafka as an integration platform for different programming languages, or maybe you have an old ETL tool, which hasn't been updated quite some time, then adding this kind of functionality on the client side is difficult. And you might have kind of spotty support, right? Because the newest feature is available for Java, but not yet for JavaScript or Go or .NET. So it can be a little bit problematic there. Secondly, of course, you have the management overhead. As James already said, right? Even if it's available for each client, we have to configure on each client. And thirdly, both our proxy as well as the Confluent client-side field level encryption are actually using an external KMS for key handling, and we believe, as I believe does Confluent, this is best practice, right? We don't want to store encryption keys. But then, of course, with the client-side solution, you basically have two levels or two integration points, right? On one hand, I need to get access to a Kafka topic to read from it. But now it has been client-side encrypted. I also need to have access to this client's KMS. So instead of just managing connections via Kafka, you now have two things which you have to synchronize. And then what do you do, right? If your KMS is just residing in the internal network, or in general, if the KMS is just, which has been used by producers, just accessible to this producer. So I think at scale, this might become an integration nightmare.
Makes sense.
Yeah,
I think we have another question as well, which is very Kafka oriented. So how does the proxy handle clients reading data from each broker hosting a leader partition?
Yeah, so basically the idea is, of course, when we drill down here, we have 3 Kafka brokers maybe. No, we have well, at least one instance of the proxy. Typically, we also have more than one instance. And the idea is then we either open up a port for each Kafka broker, and then connections on this port would be forwarded to this broker, or we use a more, let's say, advanced technique like SNI routing. So ideally, so to say, using either way, the proxy knows from which broker ID we want to read to, and then internally is mapping to this broker. And as hopefully, I hope thanks a lot for sharing the docs, James. And I kind of try to answer both questions at once.
Yeah, I just dropped the link in there. I think might be worth having a read through it, just in regards to that specific question, just to familiarize yourself. Okay. Well, I think we're at time. So unless there's any last questions, then I think we'll wrap up. Thank you for the great demo, Christoph.
Mm-hmm.
And thank you to everybody who joined this afternoon. Hope it was interesting and hope you learned something. So yeah, thank you guys. Bye.
Thank you. Take care.